This is a facility down in Mecca that's 4,000 gallons per minute. It's a very large facility, treating water from 2 wells. And now you're going to see a little video of 4 minutes that will describe what happens there.
Coachella Valley Water District's ion exchange plant is located next to Highway 86 Expressway near Mecca, California. Here, water from 2 wells is treated to remove both arsenic and chromium-6. 2 treatment processes occur within the plant. One process uses ion exchange technology to remove chromium-6 and arsenic from the raw well water. The second process removes chromium-6 and arsenic from the waste brine to reduce disposal costs. Here's how the process works. Raw groundwater from the 2 wells is pumped into a manifold that distributes the water to pre-treatment filters. Next, the raw water is brought into the plant. Through a distribution manifold, the water is sent to a vessel. There are 2 sets of 16 fiberglass vessels. Each set of vessels is called a train. Each vessel is nearly full of a strong base and ion exchange resin. The resin looks like large sand-sized plastic beads. The vessel is nearly full of this resin material. As the raw water comes into the top of the vessel, it percolates through the resin bed. The resin attracts and holds chromium-6 and arsenic ions and releases chloride ions into the water. After the water has passed through the vessel, it meets all state and federal drinking water standards. Common salt water, or brine, is used to regenerate the resin. The wastewater brine containing the chromium-6 and arsenic is sent to the brine water reactors for processing. In the reactors, the brine water is mixed with iron ions and acid. Air and a polymer are added to create oxidized iron particles that combine with the chromium-6 and arsenic ions. The mixing is stopped, and the iron particles are allowed to precipitate to the bottom of the reactors. The treated salt brine found above the sludge is removed for disposal. The sludge from the bottom of the reactors is sent to a holding tank. From there, it is sent to a filter press. Under high pressure, the sludge is pressed through the membrane. The brine water passes through, but the iron that holds the chromium-6 and arsenic deposit as a waste on the membrane. The membrane filter plates are separated and scraped clean of the waste. A hopper below the press directs the waste into plastic drums. Once filled, the drums are sealed, labeled, and transported as hazardous waste to a disposal site in Nevada.
So, removing the chromium and arsenic from the water is easy. It's dealing with the waste. You saw a lot of that was all about managing the waste that was in the salt brine and then how we dispose of it. And all that is to reduce the cost, because that's the most expensive part of the process, is disposing of the waste and doing it efficiently. So what we're doing is looking at, we know that process works, and it works well, and we may use some of that, but we have variable water quality conditions. In parts of our valley, the sulfate levels, natural mineral in our water, are too high for that treatment process. So we're looking at alternative treatment processes. We started about 2 years ago We got Water Research Foundation, national funding to help on that. And we got 2 of those research projects ongoing right now, looking at 2 alternative treatment processes. There's a lot of data now available on that. They're both expensive. They're about the same cost as what we're already doing. But that process that we're doing now might not work in some of these areas, so we may have to do some of these processes. But here's some of the pilot facilities that we're doing. Just smaller versions in these columns. In the columns here, we have the resin, and so we're testing a different type of resin that doesn't need the salt brine regeneration. And that process these tests are going to be done here in the next few months. And it was all part of the process. We started 2 years ago not waiting for the number, but knowing what the level is was very important to know what type of treatment process we could. So we couldn't go out and start installing facilities until we have the number. If it was at 1 part per billion, these processes wouldn't even have met that level. We'd have to go with a reverse osmosis, a more expensive process. So what's the impact? That's another question we always get. How much is it going to cost? What is it? So we have about 57 of our 100 wells that we think will be impacted at this level. We're going to refine that to make sure maybe we don't need all 57 wells. But currently that's what it is. We used the state's cost model and we applied it to our wells. About $518 million of capital costs. We're still researching. We're going to try to get that number down, but that's what it is now. Annualized cost of $69 million, and that's about $50 a month for every one of our customers' services. So it's a very expensive. It's doubles the cost to provide the service that we provide. And that's not going to happen in one rate increase. It would be incremental, and we're doing everything we can to try to bring that cost down with these treatment studies. But it takes time, and it's going to take time to build these facilities. This would be the largest, most costly public works project ever done in the Coachella Valley. And we're just one agency. City of Coachella, all their wells. City of Indio, all their wells are impacted. Desert Hot Springs, several of their wells. Huge impact for the valley. So we're doing these research studies. We're going to complete a source of supply study that kind of brings it all together, develops a compliance plan by the end of this year. We're going to look at our funding options. If there's grants, we'll go for them. This problem is trying to get that money for something that has only a chronic health effect. It's not an immediate health effect for anyone. But long term, they look at these risks over the life of drinking exposed to that water. That's what the regulation is protective of. So those rate a little lower than the acute health risks like bacteria or other contaminants that have acute issues. So that money often is not available to help. So customers are likely to have to pay for most of this. And we're continuing our outreach. One of the concerns we have, I talked about the arsenic rule when it came out, we had 5 years to install the facilities to comply with the rule. State of California, they like to do things a little differently. So when they come out with a new drinking water standard in front of EPA, which they have done, and now they've done it, first state in the country to come out with this chromium standard. We expect it to be effective on July 1st. Of this summer. We have 6 months to begin our compliance monitoring. So once we start our compliance monitoring and the levels are above the limit, we could be deemed out of compliance. They don't give us 5 years to build the facilities like the federal government under the Safe Drinking Water Act. They're required to do that. And the state does give time for other laws that they come out with, but this one they don't. So we are trying to get that fixed. We're working with the governor's office, legislators. We think when they come out with a new law like this, they should give us time to install the facilities to comply before we have to be determined out of compliance. So we do have a letter in the back of the room to let your legislators know, if you agree, that we think this is important, that the state should give us time to comply, give us a reasonable amount of time to build these facilities. We know what it takes. It takes time to do these. We've got a 2-year head start. Most water systems in California hadn't even started. They're waiting for the final rule to come out. With a 2-year head start, it's still going to take us at least 5 years to comply. So we're hoping that we will get some of that time. We're looking in this study at even a point of use.